It means with Rust, if we would do that, we'd have better performance by 90%. And also, which also means, because in serverless, the good thing is better performance translates immediately to better cost, lower cost. Okay, thank you, everybody. So I'm Moukarram Kabbash. I'm sorry. So I am alumni of the University of Dortmund. That's what was called at the time, university, not TU. And I am also community builder for serverless, AWS community builder for serverless, which means I have a lot of talks about serverless. I also work at a company called Azure. I will introduce like one product we are working on as an example, so you'll have an idea what I'm usually doing. Lead of software development there. And yeah, I'm an early adopter of a lot of serverless technologies. I talk a lot about them, a lot about IoT, because we are also have developed some IoT products and smart home technologies. And fun fact, my first full employee job was exactly, or almost exactly 15 years ago at this similar building on the other side of the street at Adesso 2. So yeah, it feels like going home. Thank you all. So again, hello everybody, and thank you for joining this session. As the title suggests, I will be talking a lot about Lambda, about how to use Lambda with using the programming language of Rust. I'm not a Rust programmer. I have some experience with it, so it's mainly will be about AWS and AWS with Rust. It will be less about some cool features of Rust. So please bear with me, and if you have questions, don't hesitate to ask. I don't know about the online audience, but yeah, here in the room, just ask. I can skip this slide now. I already introduced myself. So I want to start by just like a small introduction of Lambda. I know last time we already discussed what are serverless constructs, and guy talking about Azure. So it's similar stuff, of course, but I'll just give you my side of the story, let's call it, and especially about Lambda and what does it mean. So AWS Lambda is serverless computing service. That's very important. So there are serverless other services for databases, for a lot of stuff, but Lambda is a service which you use to run your code in a serverless manner. What does that mean? It means you don't have to provision your servers. There are servers there, of course. Serverless, again, the joke, serverless, still there are servers just owned by somebody else, but they are there. They are managed by somebody else. You don't need to provision them. You just say, I want to run more Lambdas, I want to do more stuff, but you don't provision your servers. It has automatic scaling. If you need to run one instance at a time, you will have it. If you need to run 1,000 instances at a time, you will get it also without you having to do anything. It has a per usage model, which means it scales up and down depending on how much you use it. You don't provision something in advance. It's be provisioned for you. You pay for what you need, and that scales all the way down to 0. If you're not doing anything, you don't pay anything. It supports a variety of languages out of the box, like JavaScript, Python, Go, Ruby, C#, or all the .NET languages. You see there is no Rust in that list, and we will see very soon now why. And it has also very good integration with all other AWS services, whether that be S3 or a service for storing files or for databases or anything else. Lambda has excellent integration in all these concepts. What the Lambda can be used for? Basically everything. Of course, it has some kind of limitations. So, for example, you can't use a Lambda for a long-running process, which needs to run, for example, 1 day long or always to be running. But anything that can be chunked up in small sizes, up to, let's say, 15 minutes, that can be put into a Lambda. And usually it's being used for automation. When something happens, do something, and then that step, and then another step. You can also use it for RESTful APIs or any kinds of API serving any kinds of data to customers or to other applications. Web applications, of course, like a simple application of this concept. Data processing, whenever you have new data, do that, aggregate some data, put it somewhere else, all that kinds of pipelining of the data. And generally speaking, for everything which is kind of event-driven applications. Whenever something happens, and we'll see how is it being pushed into Lambda. Whenever something happens, you can say run that piece of code, and that piece of code can trigger different pieces of code somewhere else. I will give you an example about like a small Lambda. So I will now just open the AWS console. It depends on the audience usually, but because now we are a Rust audience more than AWS audience, so I will do that introduction. If you have a question while I'm doing it, just ask me. I will try to make it very fast. Okay, thank you. Not this one, this one, so that will come later. Okay, so this is the AWS console. I'm in the console, and it's let's call it the starting point for AWS Lambda that you can get there when you open. You have an account. You say, okay, now take me to Lambda, and you will be put there. And here's an account where I don't have any Lambdas running. So I would say I want to create a Lambda function. Lambda function, you can have some blueprints, which means like very specific or very common tasks what you can do with Lambda. So if you do this one, you can choose out of catalog. So to process a message which has arrived at a queue, or to publish something to an SNS topic, or to process data from a data streamline, or a lot of stuff. So let's take something simple, which get starting with a Lambda HTTP, which means a function that's being triggered by an HTTP call. So I will start that using Node. Let's everything be created for me. That's the code of the Lambda. You see it's a very simple thing. Just read that file, and that's the Lambda function which is being run, and return it in a specific way. You see that object is being returned. It's the format expected from the API gateway or whoever like running this Lambda. Okay, you give me an object, has a status code 20, so I convert that to HTTP, and you have a body and everything in that. And I say, okay, I want to attach an endpoint to my Lambda. Whenever I open that endpoint, this Lambda will run. So I create this function. Okay, I need to give it a name. And it will take some time. And that time, AWS is creating the resources, creating the deployment package, because now I'm creating everything in the console. Usually, when you are deploying from your project, you're creating these deployment artifacts from your pipeline. Now it's being created for you, all the resources, which mean like the API endpoint, which to be called, the Lambda itself, and the roles for that Lambda to run. So the Lambda function has been created. You see that URL. You can open that URL, and it will run that Lambda. Okay. Again, so you have this Lambda now running, and this here, what you have possibility, you can so it attached to an HTTP endpoint. You can test it by running it locally, or not locally on AWS, but without have to call that endpoint. So for example, you create a test event, or just say test this Lambda, and it runs, and you see here the output. So you can imitate like everything. So if you want to see how your Lambda behave, if you call it with a specific URL, or you give it specific data, and you want to inspect the output, you can run it just as it is, because it's a just simple piece of code without having to run the server in front of it. So that's a simple Lambda. Like it's basically doing nothing, just returning the same code every time, and we will see what else we can do with the Lambda. So don't need the code. This is only for the cases where it doesn't work. So Rust is not supported officially in AWS Lambda. You've seen we could choose the language you want to run to deploy your Lambda code with it, but Rust wasn't out of that choice. So how do we work with that? Before we go into the solution, just let's see how Lambda works under the hood, because then you will have a better idea about how you can provide your own runtime for Lambda. So we have seen there is a code running somewhere, and the question would be, how does that code run? Where does it run? So we don't have a server attached to it or dedicated to it. How does it run? And the idea is basically very simple behind it. AWS has some kind of trigger for Lambda. In this case, it's an HTTP request. It could be anything you have configured to run that Lambda. And whenever there is a request and there is no piece of code running, there is no Lambda running at that time, it will do these steps. First of all, it will create an execution environment, which is kind of MicroVM. Fun facts, it's called Firecracker, and that's created with Rust. So even if Lambda doesn't support Rust out of the box, Lambda run on an infrastructure that's being run by Rust. So it's there. After that virtual environment is created, the next step is to download the code. So you've seen the code in that editor. It's packaged somewhere. Now that's being downloaded into the newly created environment. Then there's kind of a bootstrapping mechanism where the runtime is run on that machine. That machine will read your code. If you have, for example, importing codes in that, it will import these libraries, start at the end, and say, now I'm ready to handle your request. Give me the next request, and that's where the point where a Lambda is actually being invoked. So now we have finished the initialization, and then we started with the invocation, and that's where Lambda is running your code. So now we have a Lambda environment running. If you have a second request, which comes immediately after this request is ended, only the invocation will be called. If you have two requests at the same time, this process will be done 2 times at the same time, and at the end, if you, for example, only have one request at a time, one will be unloaded, and the one stays running. So it will be running only for max 1 minute. So this process is very fast. To create a new environment, run your code, wait for maybe 1 minute, sometimes it's less, sometimes more. If it's needed, it can be called, otherwise it's tear down. That's how it's working. So what's happening under the hood? Under the hood, you can distinguish between 3 parts of the system. The Lambda services, which is somewhere running, and that's managing your Lambdas, saying, okay, now we need to create a new environment. And then you have the Bootstrap, which is the runtime running on the virtual environment. So I've chosen to run that Lambda with Node. So my runtime is some kind of process running my code runtime, and I have a handler. And you see here, Lambda services starts a new environment called the Bootstrap program, which does some stuff, calls the init or all the part which is outside of the handler of my code, loading the code in memory, but not doing the actual work yet. And then telling back Lambda services, I'm ready, using HTTP. So give me the next invocation. That's the last line, the last arrow says, now I'm ready, give me the next invocation. And what happens? So this call will block until there is something to be called. So there's an HTTP request, there is a queue message, or anything that's need to be called with that Lambda. At that point, this call will return something back. It will return the whatever needs to be done to the bootstrapping mechanism. The bootstrapping will forward that to the handler. The handler will do the work, give back the results. The bootstrap mechanism will respond to the Lambda, possibly do some cleaning work afterwards, and then again call the next invocation like in the first line. So that's how it works. At some point, Lambda service will decide we don't need that instance anymore. It will tear it down. And in case it's needed again, it will start from the beginning. So how then can we run Rust code in Lambda? And Rust code is when it's called like kind of a custom runtime. It's different than when using Node. How does it differ? You see that line? That line is everything on the right is what you provide. Everything on the left is what AWS provide. And which means the runtime is provided by AWS. When you want to run Rust on AWS, you have to provide the runtime yourself. And you will see it's a very simple process. It actually has a lot of advantages. So whenever you want, you will package your code to include the runtime. And in that case, you won't have any additional communication between the bootstrapping mechanism or the runtime and your code. Your simple run executable will be the runtime and will be the handler. What does that mean in code? Basically, you see the last piece of the last function is actually your code. Here, in example, you are receiving also something. you processing that data and you're returning something back. So here I'm just returning JSON code. So whatever something coming to me, whether it's an HTTP request or a message, I'm doing some work, returning them back. So that's a function. Now we need to wrap it with a whole runtime, and that's what the main function do. So it just take that that function, wrapping it with a service function. Like now this is your Lambda, and to call the Lambda runtime. Now please start up the runtime, and you have this handler. What do we do next, and how do we deploy it to AWS? And basically, it's very easy. So you see, we need to build it using the environment which will be running on. So we know, okay, Lambda will use that environment, that target. Don't know exactly what does it mean, but that's exactly the architecture which will be used for this application. So we build it for that architecture. The next line say, okay, we just rename that executable to Bootstrap because that's the name is expected by Lambda, and then we zip it, and that's all. Now we have created the whole deployment package for Rust. The next step would be to deploy it to Lambda. We say, okay, now please create a new function. This function has the runtime provided with it. That's what this line says. Please don't, it's not a Node.js, not Python. I will provide the runtime. And that's the file I need to upload, the file which you have just created. And you're done. There are also some new frameworks or tools for Cargo, which we can fasten this process. So cargo-lambda, it's called, where you can use it to create a Lambda out of templates. So it will provide you with a template for that Lambda with a signature and whatever you need. And it also will build it. So you see the last command here is a cargo-lambda build release ARM64, so that you can, for Lambda, you can choose whether you want to run it on the traditional architecture or an ARM architecture. He said build it for the new one, which usually you should do if you can, because it's faster and cheaper. Not the building process itself, but running the Lambda will be faster and cheaper. And then you can deploy it either with Cargo or with the actual CLI or with any other frameworks you usually use for your code, whether it's a CDK code, if it's SAM or serverless framework. So you have a lot of options about how to deploy that function. This framework is not from AWS. It's open source, but it's not from AWS directly, although it's being referenced now on AWS pages. So if you look for Rust AWS, you will find some official documentation from AWS where you tell you how to use cargo-lambda to deploy your code or to create your lambdas, but still not officially from AWS. I think they call it closely tied to AWS, but not from AWS. Okay, so now we can create a Lambda with Node, with no hassle at all, and we can, with some additional steps, create a Lambda with Rust. So why we should care? Like, what are the advantages of creating a Lambda? Let's compare the bare resource consumption. I call it bare because it's really not loading any libraries, not doing anything, just like a simple Lambda function with returning the same result all the time, both in JavaScript, and Node, and in Rust. On the left side, you see for the case where we have initialization, and which means the Lambda, there's no running environment. That means creating an environment, calling that bootstrapping process, and then calling the invocation. So in this case, we see very big difference. You see for the node, which is the left column, it goes up to 600 milliseconds. And with the Rust, it's not even seeable. So it's like 28 milliseconds. That's really how the advantage is big. And you see, for example, here, very strange, but it depends on how libraries are loaded. With the Node.js library, not only the invocation itself or the initialization itself is slow, but also the first call is very slow. So the first call for that Lambda function took 455 seconds. And that's a non-issue with Lambdas and with serverless. It's the cold start issues. It's always very slow. Every time, even if it's very fast and it's called like a MicroVM and all of that names, the cold start is very big issue and depends on a lot of factors. How big your code is, how many libraries you're loading, how slow or fast your environment, your runtime. So it's always a big function. So imagine now you're having like an API call, and you have an init time of 1 second. So every time will be this delay. And if you have the second request in 10 seconds, then it's okay. The same Lambda will be used. If, for example, the second request came 1 minute later, all of that process, all of that delay will have to happen again. So that's a very big issue with Lambda. And here you see with Rust, of course, the issue is still there. So still an initialization time of 19 milliseconds compared to the actual calling of that function of 9 seconds, but it's much smaller. The second request after the call start has been done, and now we have the Lambda running in memory, which means like it comes immediately before the Lambda was unloaded. We still see a very big difference. So even the Node code is now much faster. So it's only 10 milliseconds, but the Rust code is still much faster. And also with Lambda, you pay for the memory you reserve for each instance. So whenever you're creating a new function, you say, I want to assign 1 gigabyte RAM for it or 120 megabytes, and you pay for that. It will come, the more RAM you assign to it, it will come with more processing powers. So it's not only the memory, but it's here you see it's consuming much less memory than the Node function. Now we have done that. Okay, so we can run code with Rust on AWS. We have a piece of code which maybe can be called by an HTTP request. What other ways do we have to call it? Because you need to maybe create a more advanced application, and of course it needs to be integrated into more results or into more services. So what other ways there are to call that Lambda function? Fortunately, AWS provide with a lot of integrations with other services, as I said in the beginning. And these integrations come out of the box. So we have seen one integration, which is integration with the API gateway, which is just the HTTP interface. Say, okay, we have a Lambda function or a lot of Lambda functions, and you can decide, okay, when I get a request, HTTP request, you can decide if you want to have like one request, more requests, one HTTP verb or more verbs. Like it's a just normal API gateway where you can route your request. You forward that to a Lambda function. The Lambda function work with it and then must return something into that format. If you are working with different services, there's always a kind of adapter. So this one is SQS, which is a queuing service of simple queuing service of AWS, which is a very high scalable queue, thousands or millions of messages in a very fast way, and you can configure it to push. Under the hood, it's polling somewhere, but it looks to you like these messages are being pushed to your Lambda. The Lambda work with that, does whatever it wants, and it's just forward to SQS at the end that was successful or not. So again, it is inside the Lambda, you don't see what's happening outside of it. You just receive some kind of a payload. You need to process it. You need to return some kind of predefined workload, and that's good. And when you are using Rust, it's opposite, for example, to JavaScript or Python, you have all the type safety which come with it. So there are libraries which say, okay, now you receive, this Lambda is being called from SQS. So you already have all the structure of the type safety coming in because you will receive exactly this kind of object with all its properties, everything defined for you. Any questions? Nice. Guess online there are also no questions. Okay, so I will show you just a small example. So now we have seen we have this first example which was doing nothing. Let's maybe look into one example which is maybe try to do more with it. This one, like I generated this code, so it's not even mine. I just told it what to do. It's said, okay, maybe I need to create a URL shortener. So I knew, okay, if URL shortener, I will need kind of an interface, an API gateway. I have three routes. One is for having kind of a page where you can create the shortcuts, one where you call the shortcuts, and actually that is it. just create a shortcut and call it. So 3 routes. One is like for receiving the web page where you can enter it, create a shortcut, or call the shortcut. So you see here, I will collapse all these functions because the beginning, the meaning of them not important. But here, same stuff we have seen before. There's a main function which initializing the lambda with the stuff it's need. We have the handler, which is the actual thing doing the work. In it, here you see, okay, if it's a post, which means like, okay, I need to shorten. Here we are doing kind of routing for poor people. So just with the ifs. Okay, so it's if I'm posting something, I want to short it, do that. And here now you see like, okay, now we are creating with this function. Maybe I need to go into it. We are using DynamoDB, which is a document database from AWS, very fast thing, also serverless. You pay like a small fee for the storage itself, but you don't pay for it as a server running. You pay for requests to read or write to it, so it's very good for these situations. Here you have say, okay, now put that thing with the ID, which is something which has been created, like a random thing. The target is a target, and it's done. And of course, where you receive the page, where it be forwarded if you want to call it. So now let's see how we done this function, how we build it. When you are working with like have actual projects, you don't just deploy the Lambda. Usually you have more resources attached to them. So I'm using here something which called the SAM framework, serverless something, I don't remember the name. It's just saying, okay, I need a function here. Okay, here I have a function, that's the Lambda function. Get it codes from this place. And additionally to that, I have an API gateway. So somewhere where I get these APIs. And I have a Dynamo table where I want to store that information. And here, please, at the end, just tell me what's the URL of this created page. So that's the whole Lambda. It has 3 resources in it. It has a connection, what is also what's allowed to call what. Here you see what's properties. Here per request for DynamoDB, for example. And I need, okay, to have only an ID and something else. Okay, now I need to build it. So the first step would be to build it using cargo. You see, I just tried it like once before I started. We came here. Okay, yeah. Sorry, just in the wrong folder. So now it's building. It says nothing has happened, or maybe it's built it. Okay. Now I need to deploy it. So I say, okay, SAM deploy, take that template file and deploy it using this AWS profile, which I stored like the credentials for them. Okay, keep the name, keep everything. Okay, confirm changes, allow to create roles, create everything needed. Okay, yes, I'm okay. It doesn't need authentication. And now it's creating the resources. It's deploying everything. It's comparing the old state of the stack with the new state. Has something changed? Okay, that's now because I don't have the URL, so maybe I need to okay, because it detected there were no changes since I built it the first time. I will just like, okay, add something here, so it will force it to build it. Sorry for that. Build again. Now it will take longer because now actually creating the executable. It will store it. You see here in this folder, in the target folder. It will create this one when you do it manually. When you do it with cargo, it will create this Lambda and say it already call it Bootstrap. So basically, it's the same what I showed before. It's built for that environment. Rename to Bootstrap and then put in this folder. So now we have created something. Now if I say to SAM deploy it, it will not say nothing has changed because obviously we have changed the code. Yes, no authentication. And now it's actually pushing that stack. Stack is like a group of resources, of functions, of tables, of everything you need for your application. It's pushing that to AWS, creates a deployment. And hopefully, in a few seconds, we will have our application up and running in a serverless manner, which means it will cost us nothing until we use it. So maybe this one here. Let me create a shortcut for this one. So it has created, okay, I mean, the shortcut is not shorter than the actual URL, but still, basically, it's a shortcut where we have created our own shortener. Again, it's not costing us anything until it's running. And you can, I did the calculation before, if you use a new account with some kind of free tier, you can run it for 1 million calls every month for about $3. So it's really very, very cheap. I will show you also some actual example with some actual numbers later on. So you will see that running code with Lambda is actually a very economic option. Okay, so we have this one. Don't need to look into the video. It's just for cases, for emergencies. Testing is simple, as I said. It's a function. Of course, it's just a kind of unit testing. All the complexities come if you have integration with DynamoDB or other sources. But basically, it's a function in your code, and you can simulate whatever input you wanted to have and assert the results. Let's have a look into now, okay, I said Lambda is a very cheap way, or cheap in a good way, not in a bad way, to run code. What does it cost, or what does it depend on? So apparently the first thing it depends on is a duration. If a Lambda function you are billed per milliseconds. If a Lambda function runs for 15 minutes, it will cost you more than if it's run for a few milliseconds. Memory CPU, the amount of that, how you allocate to it. The storage you reserve for it. The executions, how often do you execute that Lambda. Provision concurrency, like something we don't need with Lambda, and other factors. What will happen if you are using Rust? Basically, duration will go down. That will be the biggest cost factor which will go down. The memory and CPU, as we have seen, and I will show you examples from like real-world examples, also go down. Again, less money you pay for it. The storage doesn't change a lot. The execution, like number of Lambdas running could go down because now every run will take shorter, so you can have bigger batches, run them on Lambda. So again, that could be affected and go down if you use Lambda. And of course, like provision concurrency, that's something you have to do if you have slow languages and the initialization time take long. So with Rust, probably you won't need it. Again, another cost factor which is going down. So let's look into a real-world example, which we have tried. So in my company, we have IoT devices. So this one is called Grohe Guard. So it has a brand of our sister company, Grohe. And it's responsible for detecting anomalies in water behavior. So if you have a leakage somewhere, it's able to detect that leakage. It has a lot of sensors in them. And these sensors send data via MQTT, via AWS IoT service to an IoT core. That's the name of the service. So that data is processed via IoT rules in different ways. One of them is that it's being stored for queries. So Redshift is kind of data warehouse. And we use for that something that's called Firehose. Firehose is a way where you push a lot of data over it. It will batch it and will put it into a data provider, in Redshift in this case, in a good manner. So it will not overload the database. The issue with that is these payloads are binary coded. So they need to be decoded in very different way. Different devices have different schemas. Depends on the version of it. The versioning needs to be considered, and a lot of security factors. So there is a Lambda attached to that Firehose, which means the data is forwarded as it is from the device. Then inside that Lambda, it's parsed to make sense out of it, and then it's stored in Redshift. And we work with a company called Storm Reply. So they did this experiment on this function, where it took that function, and because it was one of the most called functions in our system, and they redid it in Lambda. So both in Rust, sorry. Both versions are well architected, so it's not like a cheap take on that. this function, the node function, was good architected, had a lot of optimization in it, and also the Rust function had a lot of optimizations in it. And they came up with these results. So these results here, you see, first of all, the initialization, which means there is no Lambda running at that time, and we need to start a new environment, get it up and running. And now you see we are not talking about the 600 milliseconds as we were in the first example, because now we have a lot of libraries, bigger code which need to be downloaded, a lot of libraries which need to run. So the initialization time is now more than 1 second for that Lambda. With Rust, it's I don't see the number, but of course also bigger than the number we had for that first example, for the bare-bone example. The actual call of the Lambda was also much better in this case. So you see here, I guess that would be about 600 milliseconds for that function, and the Rust function is not even seeable. So there's a very big difference. Again, these two functions are well architected. They are not like just let something be generated and we'll take it to compare stuff. It's a function which like run in production at least 1 million times every month. What does it mean in this case? It means with Rust, if we would do that, we would have better performance by 90%. And also, which also means, because in serverless, the good thing is better performance translates immediately to better cost, lower cost. You don't have to wait until like you use all the stuff you have to have some advantages financially. Immediately, a function will take tenths of the time it used to take. It will cost you also tenths of the money it used to cost you. So again, it's 1 million, same parameter as the node function. And even the fun thing is that, so for the node function, because it's big, again, it's optimized, it's minimized, so everything done what could be done. Use 1 gigabyte of RAM. The Rust function, even when you reduce the memory to 128, which translates also to much less CPU power, it will still faster than the Node.js function. So it's really a very, very big improvement. What does it mean? Now you see, like it's very, again, serverless is, or Lambda is very cost-effective way of running stuff. So what does it mean? Is it worth it? So the node function would have cost 6 euros in a month, and the Rust function would cost, not US dollar, and the Rust function will like just 50 cents. Which means it doesn't worth it if you only do for that function. But if you have thousands or hundreds of Lambda function, or you move everything to that, then it will start to make a big difference. So again, that was like the reason we didn't like go through with that. So we're still using the node function just for the reason because we don't have Rust developers.
Okay.
So it's yeah.
Amazon or for AWS, it's not a good choice because they have not so much business anymore.
Yeah, I mean, like it's just so again, the code you run is like small part of the whole system. So you have the whole I/O, which you like waiting for DynamoDB to give you something back, retrieving something from a data, which goes like in different kind of pricing models. So yes, if all your code, let's say we moved everything to Rust in an optimized way, the bill at the end won't be like tenths of the bill before that, because all the databases, all the other services, all the MQTT messages, all the number of the requests, all of that will still be the same, maybe less, don't know, possibly less, but it still won't be tenths of the money. It will be maybe lower. So yeah, maybe it is worth for them, but I mean, then like I don't know, then you will have more money to spend on something else. So, that like comes to the question: what are the final words, like what are the positive and negatives of Rust? So the first positive thing that the SDK, not the cargo-lambda, but the SDK itself is from AWS. So it's not officially supported on Lambda, but the thing you use to create that runtime is from AWS. It's fast, it's cost-effective, can save real money with it. Depends on how much you use it, maybe not a lot, but real and immediately save money. and it has everything else you like from Rust, whether that's a type safety, the compiler safety, or whatever you like. The negative, of course, AWS calls the SDK experimental. So it's even there, it's called experimental, which may be good. So if the result of the experiments are good, then maybe it will move to be an actual part or like a supported language of the system. The community around Rust in AWS, it's much, much smaller than Node.js or Python for that matter, and less mature. And also the deployment tools are not officially supported. So you see, like I have to cheat where I compile on one side and then deploy. Whereas when you're using different languages, that would be using the same tools. But still, like you could work with it. It wasn't a lot of effort, as I've seen. So when you should use Rust? I mean, it's of course left to everybody to decide. But I would say, if you are a Rust shop, if you have Rust developers, like you would be crazy not to use Rust when you want to work with AWS. Everything is possible there. If sustainability is a major topic for you, if you want to squeeze the last bit of performance out of your code, even if your Lambdas are being used to do very critical work and still don't need to provision the infrastructure you want. So that's a very good use case of it. Or if you have like no problem when using an unofficial platform or an unofficially supported languages. So there's a risk that may be let's say canceled, or the SDK may be not supported anymore. But I guess, yeah, that's a risk maybe you need to live with. At the end, thank you, everybody. If you are interested in working with AWS, have some work positions open, call me, drop me a line, however you want. Yeah, and I hope you like this talk. You learned something. And if you have questions, I will stick here around. Thank you.
Thank you very much. One moment, Oliver.
Okay. Yes, I just researched or made a small Copilot search. Azure Functions, for example, support official Rust, but I also asked what is the difference in performance, etc. What you just showed us with the really fat Node.js, which needs a huge amount of libraries to build even in Hello World. And they said that, for example, for .NET C# application, the difference is not that big. Sometimes the startup time is even faster than with Rust. But if you want at least, I'd say, a supported platform, you can use Azure Functions with Rust. But you didn't test with that.
No, because we are we have everything else on AWS.
Yeah,
so I mean, I don't. What do you mean? Like it's often supported by Azure? So you have the tooling,
I put
the
the
Rust
link
tooling
in the meetup. It's a very short. It's directly in Visual Studio Code. You download it. It's immediately available, ready, and officially supported.
Okay. Yeah, I haven't tried it with Azure for that because like everything else, all IoT platform is on AWS, so it doesn't make sense.
Then
but
it's clear.
Thanks for the tip.
I'm living on the dark side in the Microsoft world. Thanks.
Thank you very much. So first question already asked on site. I ask, is a question online, Kira?
No, no questions so far, but lots of praises, some discussion around logging in Lambdas. So, but yeah, people are already happy.
All right. Another question here, like one last question before the pizza. So I have one. So this case study was with Storm Reply?
Yes.
Very cool. So I think if you're really in for free food, they also run this kind of meetups with free food.
Yeah.
So
usually the AWS user group is at the Storm Reply, not far away from here. Yeah. Also had some talks there.
All right, then, give in another handful of applause and...
Yeah, thank you.